All right, so we have water quality of 90% in a piston cylinder, heated at constant pressure to 300 degrees Fahrenheit. So notice we're in English units. That's important to note. We're going to draw things on a TV diagram. I don't know, maybe we'll draw it on a PV diagram too. I'm just going to add it. Why not? Actually, you know what? No, it's okay. TV diagram is fine. That's fine. So we'll get to that in a second. Let's go ahead and calculate what are we going to calculate? We're going to calculate our specific volume at state 1. And I know that it's saturated because I've got a quality. So at state 1, I know my V1 is going to be V sub F plus my quality times V sub G minus V sub F. All right, so let's kind of scroll in on this. Well, it's a little fuzzy, but I think we can see it. So we're looking right here, okay, at 210 degrees. There's our V sub F and V sub G. All right, so V sub F, 0.01670 plus my quality, 0.9, times V sub G, 27.82, minus our V sub F, 0.01670. And I'm going to be a little bit lazy, put my units out here all together. So feet cubed per, and it just says pounds, it's pound mass. Okay, so there we go. Yeah, let's throw that up there. So if I plug that in, I get 25.04 feet cubed per pound mass. There we go. There's our V1. Now, I am going to make a note of what P1 is, because if I look up at state 2, I could see P2 is equal to P1, T2 is given to me. I need to figure out what P2 is, okay? So I need an actual value for that. Well, it's equivalent to P1, which there's only, at state 1, remember, we're saturated, so there's only one possible pressure that we could be at, and that's going to be the saturation pressure at 210 degrees Fahrenheit, which is 14.13 psi. PSI. Okay. There we go. Perfect. State 2. Let's go for that one. All right. So state 2. All right. So our P2 is, again, 14.13 psi, and we know that because it's the same as P1. And I'm also given that T2 is 300 degrees Fahrenheit. So I'm going to go to saturated tables that are organized by temperature. Doesn't really matter. I could have gone to the ones that are organized by pressure, but since I got a nice clean even number for T for the temperature, I'm going to use the one that's organized by temperature. So you could see, well, let's see, at 300 degrees Fahrenheit, saturation pressure is 66 and change. So we're below that. So since our P2 is less than the saturation pressure at 300 degrees Fahrenheit, it's a gas. It's superheated. So I need to go to the superheated tables. All right. So 300 degrees, 14.13 psi. Remember, everything's organized in boxes of pressure. So this is one of those cases where I'm actually going to have to interpolate, because I have a box for 10. I got a box for 14.7. I don't have it for 14.13. So that's fine. No problem. Let's go ahead and interpolate. So got a value for 10, got a value for 14.7. I need it for 14.13. So let's see. And again, we're looking at, what was I forget already. Oh, ups, I feel so silly. So we're at, there we go. That's what we're looking for. So I've got 44.99. And then I've got 30.52. If I want to interpolate, I'll go ahead and let you do the actual math for that guy, but I've got 32.27. There we go, and that's going to be feet cubed per pound mass. Perfect. And so now I fixed my state for state 1 and state 2. Let's go ahead and draw things on a TV diagram. So I'm going to draw my little vapor dome. Okay, there's temperature, there's specific volume, meters cubed per kilogram, and degrees Celsius. Remember, it was a constant pressure process, so I'm going to draw a little line along constant pressure there. State 1 was two-phase. State 1 was two-phase. State 2 was superheated. So we'll just kind of make a note of that. Oops, and I realize, degrees Fahrenheit and feet cubed per pound mass. Somebody was probably screaming at the screen. I don't know, maybe not. So we'll put there's state 2, superheated, there's state 1, two-phase, and there's the process path between them. Here's state 1, V1, 25.04, and this guy is 32.227 feet cubed per pound mass. Let's see, there's T1, T2. T1 was 210. Actually, these ones were given to us, weren't they? All right, that looks good, doesn't it? I think we got everything there. I'm going to zoom out just so you can maybe see the whole picture if you need to. But there you go. So hopefully that was helpful. Let me know if you have any questions.